speaker is Thorsten Meinl from KNIME itself, who, as you'll have noticed, KNIME have been mentioned several times throughout this morning, which is the main platform by which the Cosmos computational tools are being delivered. Okay, looks like we're good to go, so I'll give the floor to Thorsten.
Okay, so thank you, Steve. Welcome everybody to this last part of this morning session. So my name is Thorsten Meinl. I'm working in the company that's developing KNIME, and I want to give you a very short and brief introduction what KNIME actually is. If I want to tell you all the full details, it would probably take 2 or 3 hours or even more, because we also have our user trainings, for example, which take 2 days. So it's really only a rough overview that you get the feeling how KNIME works and why KNIME was chosen in the context of the Cosmos project. So why did we choose KNIME? This is a short excerpt from the Cosmos project proposal that was written 5 or even 6 years ago, and I highlighted some part. For example, that one of the aims was to develop an integrated suite of open source and open access computational models. The important part here is the open, because one of the aims is that everybody can reproduce everything we have developed in these 5 years with its own data, so that everything is completely transparent and you can validate it. The other part is in silico workflows. Elena has already presented many experiments that we do in silico, only based on the computer. And also the bottom part, a future-proof set of building blocks. So we don't build anything monolithic stuff, or we don't reinvent the wheel. We really want to develop building blocks that you can attach them to yourself and then create probably new analysis workflows. So, and for that reason, one of the 6 work packages in the Cosmos project, work package 5, is about KNIME and extending KNIME with the necessary technologies so that the Cosmos project can benefit from it. And here, 4 of the key points that we addressed in this work package 5. The first one is to provide an easy access of the developed models to the users. So the models that Alicia, for example, with her colleagues in the JRC developed, should be easily accessible to users. They are implemented in R scripts. You can now argue if this is easily accessible or not. The good thing about KNIME is it can easily be integrated into KNIME with just one node, and then you can use it even if you don't have much knowledge about R. The second point is that we wanted to create scientific data analysis workflows using both these new developed models, but also using existing technology. So as I said, we didn't reinvent the wheel in many places. So we used existing technologies wherever possible. Third point is we built a publicly accessible repository of scientific workflows so that everybody in principle can access these workflows, use them with his or her own data. And then also the fourth point is to enable the easy usage of these workflows. You can either use it directly in the KNIME application, but this requires a bit of knowledge of how KNIME works. Or if you really just want to process your data, you can access all these workflows also via web browser. And in the next session, we will show you how these workflows in the web browser actually work. So, and how does KNIME now fit these 4 points that I have just shown you? They can very easily be mapped to these four parts here in this diagram. So at the bottom we have the KNIME nodes. KNIME nodes are simple building blocks that process data or that build some models. So they're really isolated blocks. If you use these KNIME nodes, you can combine them to KNIME workflows, which then perform an analysis of a data set, starting from reading the data, transforming data, building models, and then producing results. I will show an example in a moment. On top of that, we have the KNIME server, which in its base version is just a simple repository of KNIME workflows, where you can upload and download your workflows. And on top of the KNIME server, we have the KNIME WebPortal, which allows you to execute these KNIME workflows that are stored on the KNIME server in a web browser without needing to install an application or without needing to know how KNIME works. So now, what is KNIME actually? The desktop application consists of nodes, and here's an example of a node. This is the partitioning node. So every node performs a certain functionality, as I already said. You see it has an input where the data comes in. The data format in KNIME is just a simple tabular format, so you have columns and rows. And almost all nodes also have outputs. In this In this example, the partitioning node has two outputs because it takes the input table and splits it into two halves, and then you get one half at the top and one half at the bottom. Below the node icon you see this traffic light, and the traffic light tells you in what state the node currently is. Usually at the beginning it's red, which means the node needs some additional information. In the partitioning node, for example, you can set which rows should be end up in the top partition and which rows should end up in the bottom partition. For example, you can set it to 60 to 40%. If you set the configuration and the node turns to configured and then shows this yellow traffic light, and then you can execute the node, which means it reads the data from its predecessor that's coming in by the input port, processes the data and produces data at the output port, in this case at the two output ports. And then it turns green, which means it's executed, and then you can also immediately look at the results that the node has created, in this case at the two output ports. So now you can take as many as you like of these nodes and combine them together into a workflow. And the workflow can look, for example, like this in the bottom. That's a quite simple workflow. So it starts off, do we have a laser pointer actually somewhere? No, then I'm just pointing here. So it starts off with the file reader here at the beginning, which reads a simple CSV file. Then some nodes that add some color information, for example. Then here we have our partitioning node that takes the input table, divides it into two parts. The first part is used in a node that builds a decision tree based on the first partition, and the second part is then used in order to predict the data together with this model here, and then you get your predicted results, and in the end you can use scatterplotter to see how the prediction was, and also a scorer to see how good your prediction is. So these are workflows. These workflows you can easily build them in your KNIME desktop. This is how the KNIME desktop application looks like. It may be a bit overwhelming at the beginning, but at the top left you have your repository of the workflows that are on your local computer from which you can choose. On the left bottom you have all the available nodes. So currently we have about 1,000 different nodes available. You don't need to install them at all at once, because they are ranging from all different application areas: chemistry, text processing, business analysis applications, image analysis, and so on. So the 1,000 have a broad range of applicability. In the main part you see the workflow editor with the workflow that I have just shown here. On the right part you see for every node a short description, what the node actually does, what the configuration options are, what the required input is and what the required output is. And then you can always open or have a look at the output of the node that the node has created with so-called views. So these are 3 examples of views on the data that's currently available inside the workflow. So here you see just a look at the data table that the node has been created. This is a more sophisticated view showing a histogram, and at the right you see the decision tree model that has been built by the node that is marked here in the center. I will show you a live demo later on. Then you see how it actually works. Regardless of in which application area you actually use KNIME, the basic concept or the basic steps of a workflow are usually quite similar. So you start off usually at the first part with data access. So you have data lying somewhere, can be a database, can be files, text files or structured files like XML or JSON, or even data sitting that you query from some remote web services. So we have nodes for all kinds of data sources where you can read in your data and get it into your world. And then the next step will be, and that's in many cases the most complicated step, or where you spend most of your time, is transforming your data so that it's in a format that you can actually use. For example, removing certain parts of your data, removing missing values, transforming it, applying some constant formulas to it, and so on and so on. So that's really the data transformation part, or doing aggregations, for example. The next part will then the scientifically most interesting part, which is the analysis of the data and the data mining, so building models out of it, like decision tree models, doing regression on numerical data, clustering, and of course also validation. If you have a model, then you need to validate if your model is actually performing quite good, also on unknown data. You can do PCA, multidimensional scaling, and what's quite important is you can also integrate external programs or external scripts, like for example R and Vega. So the models that JSC has developed, as I said, have been implemented in R, because R is just perfect if you have statistical numerical computations. And so there is a KNIME node that calls out to R using a script and then does the computation inside R and then gets back the results. The next part will then be visualization, so you can just have a simple look at the data table. You can build all kinds of graphics like histograms, scatter plots, maps, also integrated quite a few of external tools for visualization like J3 chart, or again you can also do visualizations or create diagrams using external tools like R and Python. And then the last part is the deployment. The deployment can range from very easy tasks like writing your results back into a database, creating Excel files, something like this, or you can also create nice reports, which we will see later on when you use the WebPortal, so like PDF reports with tables and images in there. Everything can be done in KNIME. As I said, we have over 1,000 native and embedded KNIME nodes currently ranging in all categories. These are nodes that are provided by us, but there are even more than these 1,000 KNIME nodes. For example, when it comes to chemistry, there are also integrations of known toolkits that are not from our company, but that are from research institutions or other companies. So here are 3 examples. For example, the RD-kit nodes, which are developed by Novartis, can be integrated into KNIME. Also the CDK nodes, which are mainly developed at the EBI in Kingston, have been integrated into KNIME. These are open source nodes, these 2. And the third example is, I think all of you know ChemExon, and Infocom, which is a Japanese company, has integrated many of the ChemExon functionality also into KNIME nodes. These are commercial extensions then in the end. And there are many more. So you can usually group these extensions into 4 different categories. The first one is they are donated by companies like RD-Kit or what Cheminformatics, which is provided by Eli Lilly. Then there are extensions which are maintained by us. Then there are other extensions which are contributed by research institutions like SECAN or OpenS, for example, which are contributed by the universities of Berlin and Tübingen. They are more for bioinformatics related tasks. And the 4th category is really our technology partners like ChemExon, Schrödinger, Triforce, and so on. So now for a short KNIME demo. So KNIME itself is completely open source and free, which means you can download it from the internet, install it on your computer and use it without any restrictions. The only thing, times when you have to actually spend a bit of money if you're using, for example, extensions from our partners like the ChemExon tools or Schrödinger, for example, but the rest is completely free. So this is how KNIME looks. As I said, in the top you have your repository of workflows that are on your local computer. This is the repositories of available nodes. This is only a subset of all the nodes because I've only installed the extensions here that I need for the demonstration here. Here's a description of the node that is currently selected, and here you see a console where some error warning messages are presented. So then you usually start off by creating a new KNIME workflow here. Give it a name, and then you get this empty workflow editor here, and now you can start creating your workflow by just dragging and dropping nodes here from the repository into the workflow. So I'm starting here with the Marvin sketch node. That's a free node from ChemExon actually, so ChemExon provides these 4 nodes for free for everybody, so they don't require a license, you just can install them. So Marvin sketch allows you to draw a structure. If you double click on the node, then the dialog of the node opens where you can now set the configuration for the node. In case of the ChemExon, the Marvin sketch node, the configuration is just the molecule you want to display here. So I'm drawing a very simple molecule here, like for example this one here, and then you can click OK. Now the node is yellow, which means it can be executed, and you can right click here and execute, and then it processes the data. In this case, it doesn't really process any data because it's an input node that doesn't have any input ports. And then you can actually look at the data it has produced, and well, no big surprise, it's just the molecule that I have drawn here. Now I can use this molecule and feed it, for example, into the CDK nodes if I want to, for example, compute molecular properties. So I take the molecular property node, drag it into here, and then I connect these 2 here. I need to change the format because this node outputs the ChemExon internal format with which other nodes cannot deal really. So I tell him that the output should be SMILES format, and now this molecular properties node is happy. It even works without explicit configuration, but here in the dialog you can now set here which properties you want to compute on the molecule. So I'm choosing just all of the properties, and then you can execute the node. And then you get again an output table with the molecule, and then all of the computed properties are now here in additional columns in the single row here. And then in the next part you can, for example, compute the x log p, can execute it, and then you will have another additional column with the x log p in the end. So now we can go on. For example, you can now use your molecular properties that you have calculated, use them in a decision tree with one data point. Of course, it doesn't make much sense, but assume you have a larger data set, and then you can compute your models here. And now I'm going immediately to one of the workflows that have been developed in the Cosmos project. It's not a very complicated workflow, but I think it's quite easy to demonstrate how it works. So the first part looks similar, so you can sketch a molecule, then properties are computed, and then there's a math formula node, which is a very general node, which then uses these computed properties in order to compute the skin permeability based on the properties that are here. Then this one is rounded to double because we only want to have several digits. And then in the end, all the data is fed into this data to report node, which means we can now use this workflow and create actually a report. So I can click here on this little icon at the top, and then you see the report that we have only defined. This is just a development perspective of the report. Again, in order to get to know this, you need a bit of experience. But I now can just say here I want to run the report as PDF, and then it takes the data that has been processed in the workflow, uses this report template, and then creates a PDF file with the final results here. Yeah? So you see the title of the workflow, when it was last modified, a short description of the workflow, and then here the molecule that has been drawn and the predicted Kp value here. These reports can then later on also be downloaded from the KNIME web portal when you use the very same workflow in your web browser. You don't see any nodes, you just see required inputs, and that you will see in the next case. So this was the local desktop application. I've also told you that there is the KNIME server. The KNIME server really is a central component which becomes important if you're working in a larger group with people where you want to exchange workflows. The KNIME server is in its very base version a very simple repository where you can share workflows, you can share data files, you can also share meta nodes, which are like encapsulation of smaller workflows. It also allows remote execution, scheduled execution. You can set access permissions to individual groups, that some groups can only see different folders on the server. You can integrate custom applications. You can access the server, of course, from your KNIME desktop application. If you remember on the top left, there was this repository of local workflows. You can add there additional mount points where you can access the workflows that are residing on the server and can edit them from here on. And the KNIME server also enables this web browser. So this is an example of the workflow repository, as I said. So you can add an additional mount point, and then you see the workflows on the Cosmos KNIME server. Yeah, you can up and download them and also edit them directly via double click. The KNIME web portal, which is now probably the most important part when it really comes to using these workflows in a broad audience. It allows the executions of the workflows in any web browser. It's like a wizard-like execution, so you start with the initial page where you provide some input data, then you go to the next page and then can select some parameters for your algorithms, then you go to the next page where it's processing, and in the end you get the results back. And you can download the results as files, or you get a PDF report and so on. The Cosmos KNIME server is a special instance of a KNIME server which is currently hosted in Bradford. It allows public access for anybody after registration with Cosmos Space. All the workflows that we have developed, or almost all of the workflows that we have developed in the context of Cosmos, will in the end be available via a web portal workflow. The detailed documentation of these workflows are in Cosmos Space, and you can access the server at this address here. I think it's also written in all the leaflets. So let me just show you a short example of the KNIME server. We will see more examples than in the next session. This one here is not the public version of the server. That's currently the development version, which also has the nice Cosmos layout that will be put public in 1 or 2 weeks or so. So if you go to the start page, you see a short description about what Cosmos is, what the Cosmos KNIME server is. There's all the links here. Then you can log in here, and if you don't have a login yet, it explains you here at the bottom how you can create a login. So I'm now logging in here with my, and then you see here it doesn't look like KNIME at all. It looks just like a normal web page. On the left you have again the workflow repository. with a public and private folder. I'm currently administrator on the server, therefore I'm seeing all folders and all workflows. If you register now at Cosmos Space, you will only see the workflows in the public folder here. And then you can browse to the individual workflows. For example, this skin permeability estimation workflow that I have just shown in KNIME. We can execute in the web portal. You can just click on the workflow here. Then the workflow is loaded in the background. You see a short description of the workflow. Then you can start the execution. Then you can ignore this error message here. Then again you can draw a molecule. And then you can click next. And now the workflow is executed in the background. The values are computed and the report is generated. And here you see the results. You can download the results as a CSV file or again view the report as a PDF, for example, or as a PowerPoint. Okay, that's about it what I wanted to tell you about KNIME. In the next session we will see many more of these KNIME workflows in action, what input is required, what results they produce. So much for KNIME. If you're interested, again, you can download it from our webpage. If you're even more interested, you can come to our user trainings and just try it out.
Okay,
Yeah,
thanks.
thank you.
Thanks, Thorsten. So, does anyone have any questions for Thorsten?
Nora Abdullah from Unilever.
Yeah.
Hello. This is a really basic and maybe even stupid question, but I wondered how can KNIME communicate with pipeline pilot?
We have a node actually where you can call out to pipeline pilot protocols from inside a KNIME workflow. That's possible.
Okay.
Yeah.
Is it publicly available?
That's also publicly available. Yeah. So that's among the many extensions
So
that
we
you can...
won't need to contact you to ask for anything to be done?
No, you can download KNIME and then install this pipeline pilot connector, I think it's called.
Thank you.
Yeah.
Anything else? A question at all?
Richard Marchese Robinson from John Moores University. Thank you for the talk, Thorsten. I just wanted to know, will the actual workflows themselves developed within Cosmos be available for download and editing in the future under open source licenses? If so, which license will be used?
A good question. I mean, they are already available via download. If you create your Cosmos Space login, you can access it via the web portal, but you can also access it directly to server via this mount point. So you can create a mount point in your KNIME desktop application, then you also see the same workflows, can download them. But that's the idea. Under which license they will be released, I don't know. We haven't discussed this yet. But it's probably a very, very open license because everything is published that we have developed here, and so...
Yeah, I guess that was stealing my point that I was going to mention at the end, is that the question that was raised during the previous talk about the availability of the workflows will be available as Thorsten demonstrated through the web portal, which you can log in, but you can also use the Cosmos Space to download the raw KNIME workflow if you like, and use it on your local install, and then you can do whatever you want with it. You can modify it, play around with it, hate it, like it, whatever. So you'll have that freedom. And of course, the web portal versions are kind of hard-coded, if you like, because they're behind they just run as you saw. So I think it answers that question.